Ladies, in today's class, you completed the triangle challenge. If you recall, you were given some pipe cleaners that contained a length of 8 inches and 12 inches, and then you were tasked with completing as many triangles as you could with those pipe cleaners. And you were also given an angle of 30. So in some situations, you found only one triangle that contained a length or a side of 8 and a side of 10. In another case, you tried your side 8 and a side of 2 inches, and you found that 2 inches was not long enough to create a triangle without changing this 30-degree angle. So there was no triangle in this second case. And then in the final case, you found that when you kept the 8-inch side and used a 7-inch, some 6 inches, some 5 inches, that you were able to create two completely different triangles with that given information. And right at the end of class, I told you that this case is called the ambiguous case. You may or may not know that the word ambiguous means not clear or not able to know the difference between one thing or another. So if something is ambiguous, it's not clear what we're looking at. So if we look at these three situations, we have the ambiguous case because we could possibly have one triangle, no triangle, or we could have two triangles. And we're going to look at examples in our notes today from Goal 4 on how to identify that we have the ambiguous case and how to solve for it. The first thing I want you to note is what I've highlighted. I'm going to go back over each of these in yellow highlighter. Notice that if I highlight the given in every triangle, I am highlighting two sides and the angle that is not created by those sides. So two sides, S, S, and the A goes on the end because this is the non-included angle. Look in the second example. Two given sides and a given angle that is not included. So side, side, non-included angle. And in the last two examples, two sides and the non-included angle. So if you have this combination of two sides and the non-included angle, or an SSA triangle, then you have the ambiguous case. And it's possible that you'll have one triangle only, no triangle at all, or two separate triangles. Let's look at our first example. All right, example number 1. So goal 4, solve, if possible, the triangle or triangles for the ambiguous case. Example 1, solve triangle XYZ, and then it gives us angle X, and side Z. Notice you're not told that this is the ambiguous case. So the first thing I would suggest is drawing the triangle. We don't know if this is an acute triangle, a right triangle, an obtuse triangle, equilateral, isosceles. So I would just draw any triangle and label this angles X, Y, and Z, and then appropriately label the given parts. So angle X is 43 degrees. Side X, the side opposite angle X, is length 81. And Z, the side opposite angle Z, is 62. Now that you've drawn the triangle, you can analyze the given information. We have a given side, and a non-included angle. So I know that this is a side-side or non-included angle triangle, or SSA, and this is what tells me that I have the ambiguous case. There are several tricks that, I don't want to call them tricks. There are several things you can check in advance to know if you're going to have one triangle, two triangles, or no triangles. But I think that requires quite a bit of extra work. So my suggestion would be to dive right in, set up your proportion, and see how many triangles you come up with. So let's look at that. I know that I have enough information to set up a proportion using law of sine. So I know that I can solve first for angle Z. So I'll begin with the sine of Z divided by its opposite side is equal to the sine of 43 degrees divided by its opposite side. So I have my proportion. There's only one variable, so I know that I can use law of sine. So I'll isolate sine of Z, and now take a moment and type 62 times the sine of 43 degrees divided by 81 into your calculator. And you'll see that the sine of Z is equivalent to 0.5220. Recall, because you're solving for an angle, you will have to use the inverse sine value. So we'll see that angle Z comes out to be 32 degrees. All right, so let's go ahead and label angle Z as 32 degrees. And now that I know two angles of my triangle, I can go ahead and find the missing angle by finding the sum of 43 and 32 and subtracting that from 180 degrees. So take a moment, pause the screencast, and find the measure of angle Y. And I'm finding that angle Y is 105 degrees. Okay, so we know for certain that we have at least one triangle. I've solved for every piece of that triangle except for side Y. So now let's set up our proportion to solve for side Y. So we know that we need Y, and remember we talked about putting the variable in the top left, so Y divided by the sine of 105 degrees is equal to, remember we also discussed sticking with our given information, so since whenever possible. So since 43 degrees and 81 was given, I will use 81 divided by the sine of 43 to finish out my proportion. And then take a moment and multiply 81 sine of 105 and divide by the sine of 43 in your calculator. And you should come up with a Y coordinate, or a Y value, of 114.7. So now we have solved for all three sides and all three angles of our triangle. So since this is side-side angle, we know there's a possibility now of having two triangles. We've already eliminated the possibility of no triangle because we solved this beginning first triangle and came up with valid values for all. So how do I prove whether or not I actually have a second triangle? Let me show you. If we go back to this scenario of two triangles, I want you to look at angle C on each triangle. Okay, so you're focused on angle C. I'm going to pause the screencast for just a moment and so I can re-sketch those. Okay, so I've taken the two triangles and I ask you to look at the angles of C. And I have combined them into one sketch. So I'm going to trace with yellow the original triangle ABC with the two sides of 7. And you would see that this is one triangle. And now I'm going to trace in blue still side 8 and the other side 7, and then go back to A. And you see that we have a second triangle. So triangle ABC, and if you see I'm putting the subscripts for triangle 1, and then ABC, the subscripts for triangle 2. So this represents the given information for A for both triangles, given information for B for both triangles, but C changes from one triangle to the other. And I want us to focus on this relationship between the two different angle C's. Do you see that the sum of these two angles is 180 degrees? They form a straight line. All right, so if we go back to our original example, in order to determine if there is a second triangle, then I have to first find the supplement of 32 degrees. Okay, how do I know that I'm finding the supplement of 32 and not 105? When we were solving this triangle, the first angle that we solved for was 32 degrees. So the first angle that you solve for is the one that you check its supplement. Okay, so let's do that. I'm going to draw the given information, X, Y, Z, 62, 81, 43. That's the given. So my angle Z should be the supplement of 32. So 180 minus 32 is 148 degrees. Okay, so now we know angle Z. Go ahead and find angle Y. So 180 minus 43 is 137. And 137 minus 148 gives us a negative number. So you'll see there's not room for a third angle here. The sum of 43 and 148 is 191. The sum is greater than the sum you can have inside a triangle. So because 148 plus 43 is 191, because it's greater than 180, we know that there is no second triangle. Don't worry, we're going to talk about checking for a second triangle again, and I will reiterate this a second time for you.